All right, we had a free response that I wanted you to do today, and it had a really important component to it. And that component that I really wanted you to understand was simulations. Well, first of all, you were asked to see if the first of all, it was just a basic running of a test. Perform a test of significance, determine where the average amount of juice dispensed is different from 12.1. So that's a one proportion Z test. And it did say assume the conditions for inference is met. I do expect that if you are doing more than one inference procedure in your free responses, that probably one of them you'll be doing the assumptions for. One of them may not have to. The conditions may already be met. So here we had to go run a full phantoms, naming without the assumptions. Parameter is mu because it was about the average amount of juice dispensed into juice bottles by this machine in the past hour. Okay, so we were just doing it per hour, so that mattered. We're generalizing to the population of all of them. The null is that it was 12.1. Of course, the alternative, it said, does it provide evidence that they were different than 12.1? So that's why it was not equal to here. The assumptions were stated. The name of this was a one sample t-test for means. Now, I went and put it in my calculator under t-test. So in your calculator, you can see here I put the null hypothesis as 12.1 with the sample results of 12.05, the sample standard deviation 0.085, and we had a sample size of 4. And again, they wanted not equal to. So it gave me these results. So what you have to list down, besides naming the test, is you want to make sure you included the t-score, and that was negative 1.18, the p-value, 0.32, and the degrees of freedom. And for the average, the one sample t distributions, it is sample size minus 1, so that's why it was 3. So obviously, oh, I have the wrong sign right there. So obviously 0.32 is greater than alpha, so I failed to reject the null hypothesis. And so therefore I do not have evidence of HA. So remember, you're stating what you're doing with HO, and then if you do or do not have evidence of HA. All right, so here in context, here's where I think the primary component that you might have missed is. So let's take a look at this. Here they were talking about that they ran a simulation. So the running of this simulation, they were still same size samples of size 4. They set the simulation so that the mean was set at 12.1 with a standard deviation of 0.05 per sample, I guess. And so then they ran the simulation and got 300 values. So what that's doing is that's telling us, hey, this is where we would expect the data to fall according to the parameters that we set forth of a mean of 12.1 and a standard deviation of 0.05. So the dot plot displays these values. So each one of these dots represents a sample of 4, and they took a sample of 4, averaged it, and got the average. And actually, these, I believe, are the sample standard deviations. Okay. So that's what they don't have a label here, but that's what that would be. These are the standard deviations, not where all of the means are. So they want to look at that. They say, use the results of this simulation. So make sure you are doing that using the results of this simulation. Okay, to explain why you think the sample provides or does not provide evidence that the standard deviation exceeds 0.05 fluid ounce. The results they got was at 0.085. So maybe that was this little guy right here. Okay, they got a standard deviation of 0.085. Now, so this language here should have kind of jogged some thought processes in your mind. provides or does not provide evidence that the standard deviation is exceeding 0.05. That to me sounds like we're talking about an HO with the standard deviation at 0.05, an HA with the standard deviation exceeding 0.05. So I'm thinking, this sounds like evidence of a test. And what do I have to do for evidence to say that I have evidence or I don't have evidence of HA? I need a p-value. So what happens is we get that p-value from this picture from the simulation. Because remember, p-value is the probability of getting this sample or something more extreme if the null is true. So when they set the parameter with a standard deviation of 0.05, here was the results they got. And here is the simulated p-value. The p-value is the probability of getting this sample or something more extreme if the simulation is set at 0.05. So that means that we've got, if I count how many samples gave me this upper amount, that's 12 out of the 300, which is 0.04. So 4% of the simulated samples gave me a standard deviation of 0.085 or more when the simulation was set at 0.05, if the null is true. Okay? So therefore, what do you think about that? We got one of these guys. We got a 0.085. And that is not very likely to have happened. Less than alpha. So that means, again, I kind of wrote out here, there's only a 4% chance of getting those 12 out of 300 standard deviations that are 0.085 or more. Okay. And since that is less than our alpha of 0.05, it seems to provide evidence that, kind of what HA is, that the sample standard deviation exceeds 0.05. So that's the big deal. That's what we were going with. That's what our sample, our simulation is doing for us, is it's simulating this so we could calculate that p-value for those sample standard deviations. All right, so I hope that made sense for you and you feel comfortable with uh, interpreting the simulation and its p-value.